Now we will see the factors affecting the velocity of sound. So the first one, we will just study the effect of temperature. So we have just seen that velocity is nothing but gamma p upon rho. Then rho, what we know that rho is nothing but mass upon volume. So this gamma p is nothing but mass upon volume. So this one definitely, again I can write it down. So gamma pv upon m. So definitely what will happen if the temperature is going to change? Yeah, so this pv is equals to RT. So this velocity is equals to gamma RT upon m. Yeah, so definitely you can say that. So v is equals to, or v is proportional to the square root of t. So if the temperature is going to be changed, which will affect your velocity of sound, so it is proportional to the square root of t. So it is proportional to the square root of t in case of, that is the effect of your temperature on velocity of sound. Yeah, so velocity is going to increase over there. So similarly, what is the effect of pressure? So we have to see now what is the effect of pressure. So again, v is equals to, you can write it down, that is a gamma p upon rho. Again, rho is equals to mass upon volume. So velocity is equals to, again, gamma p, which is mass upon volume. So velocity is equals to gamma pv upon m. Yeah, so now effect of pressure. So even if the pressure is get changed, so you can say that still, yeah, so definitely according to which the volume is going to change. Yeah, so if pressure get increased, volume is going to decrease. So the pv is always remain constant. So it doesn't change the velocity of sound. In short, it doesn't change the velocity of sound. Yeah, so you can say that it doesn't change the velocity of sound. So we can write it down, the velocity of sound, which is your gamma p upon rho. Again, that rho is equals to density, then velocity, let's say for a particular medium, that is a gamma p upon rho 1, then v2 is equals to gamma p upon rho 2. So if you just take the ratio of v1 upon v2 is equals to rho 2 upon rho 1. So simple, you can say that it is inversely proportional to the square root of rho. So that is the effect of velocity on the density. So if obviously density is more, so the velocity is less. Then if you talk about the humidity, so if you just talk about the humidity of your atmosphere, yeah, so for humidity, again you can say that, so we can say that the air is moist. Yeah, so for moist air and for dry air, so let's say for your moist air, yeah, and then for your dry air, so dry air generally the density is greater, and for your moist air it is generally, again it is a 0.8 or around 0.9. Yeah, so you can say that obviously based on this, so the density of your dry air is greater. So the density for the dry air is greater, so v is inversely proportional to the square root of rho. So this density is greater, so the velocity of sound through the dry air is less and it is greater through the moist air. Yeah, so that is one of the reasons. So you can say that, so for that your moist air, so which consists of mainly your H2O water molecules, so its density is less, so which will make the velocity of sound through those moist air is greater. So that is the effect of your humidity on the velocity of sound over here.